All right, I don't know how you guys chose to do these. I did it by the addition method, the elimination method, but they're set up nicely for substitution as well. You just have to, figure out what you like the best, what you're comfortable with. Please let me know if you don't agree with me here, because you could be taking a quiz very shortly on solving systems of equations. Number one, I got 2, 3.
Yeah, I got that right.
And number two, I got 3, 1.
Yes.
Stop me if you have a question.
About the checking thing, 'cause it's like so much better.
Tell them about the checking thing.
Check then and like print the y so you can make sure you got it right.
Oh, absolutely. Now, the way we learn how to do this is by elimination, substitution, or by graphing. Yesterday we did by graphing, right? You can put both of these into slope-intercept form and check them in the calculator. Like this one is not that hard to do. Y equals negative 3x plus 3. This one takes a little bit more work. This is why you got to be really good at going from one form to another. Negative 4y equals x minus 14. Do you see what I did there? I moved the 14 over. Then divide everything by negative 4. Y equals negative 1/4 x plus 14 over 4. And then you can do it in the calculator. See where they intersect. That would work. Now that's not as easy to do when we do word problems, which is what we're doing today. So I do want to make sure you've got your other skills in your toolbox as well. So I got 2, 3, and 3, 1. Do we need to see one of these, either of these, both of these worked out? Which one? Number 1. Okay, you need to tell me, are you an elimination person or a substitution person? Elimination. Okay, so I need to make sure that the only way that elimination will work is your x's, y's, and everything have to be lined up. So I usually put them in standard form. So on number 1, I'm going to move the y over on that top equation. So I got 3x minus y equals 3. See what I did there? Okay. On this one, my x is already positive. I'm just going to leave my x alone. I'm going to bring the negative 4y over to this side. So what's it going to become? Positive 4y. And I'm not going to move the 14, so it's just going to stay a 14. Do you see what I did there? And now, I can either multiply the bottom equation by negative 3 and make the x's cancel, or I can multiply the top equation by positive 4 and make the y's cancel. It's up to you. Okay, so I'm going to multiply this bottom equation by negative 3. That would give me negative 3x minus 12y equals negative, what is that, 42? Yeah, negative 42. So now I'm adding up the blue one on top and the red one on bottom. That's going to eliminate the x's. Negative y and negative 12y is negative 13y. And a positive 3 and a negative 42 is negative 39. And negative 39 divided by negative 13 gives me a y value of 3. Then go back to any of the equations and put a 3 in for y somewhere. I would probably use this original one right here. If I put a 3 right here, I would get 14 minus 4 times 3. In other words, 14 minus 12 equals x. And 14 minus 12 is 2. So my x value is 2, my y value is 3. All right, anything else? The second answer was 3, 1. Positive 3, positive 1. Do you need to see the second one? Okay, did you do addition or did you do addition? Okay, so tell me how you rearrange stuff, because there's different ways to rearrange as well. Okay, so you had x plus y equals 4. Okay, so far so good. What'd you do on the bottom one? Okay, so then you would have positive 2x plus 3y equals 9, right? Then what? Multiply the top one by negative 2. That'll work. My new equation then would be negative 2x minus 2y equals negative 8. And then when you add them up, the x's are eliminated. 3y and negative 2y is just y. And 9 and negative 8 is 1, so the y value is 1. I would probably go back to this one right here, the original top equation, put a 1 in for y. What's 4 minus 1? 3. So x is 3. 3, 1. Okay, get out your homework. Your homework was to solve systems of equations by graphing. I'm going to pause while we grade homework real quick. Okay, the title of your notes today is Coin and Mixture Problems.
Oh my god, is this we're learning with the coin and freaking keychain?
Yes, after today's lesson, you should be able to solve that keychain and coffee cup problem that was on the mock star. Remember that? And it's not by guessing and checking. We're going to learn how to do it much easier. The coin and mixture word problems is what we're doing today. Okay, please read this problem about Eleanor. Let it sink in, let it soak in. Okay, these are called coin or mixture problems because we're mixing together things that are worth different amounts, different values. Like the keychain and coffee mug problem, they cost different amounts. And then they totaled them all together as to how much money was made. The same kind of thing is happening here. We've got a mixture of what? Nickels and quarters. Are nickels and quarters the same amount? No. This is actually a system of equations. There's enough information here to make two separate equations about the facts that they're telling us here. And we're going to solve those two equations either by substitution or addition. We won't have to worry about guessing and checking because that takes forever. Usually in these types of problems, one of the equations is about the number of items, like the number of coins, the total number of coffee mugs and keychains, the total number of coins, or how the numbers relate to each other, something about the number of items, and then there's also one that's about the value of the items. So that's usually how the two equations break down. This first sentence right here is the one that's telling us something about the number of items. It doesn't have anything to do with money. It's just literally if you counted her coins and made a stack of her quarters and nickels, what you'd notice is that her quarters are 3 times her nickels. What does she have more of? Quarters. Well, what equation does that look like? Let's use Q for quarters and for nickels. Okay, or is where your equal sign would go. Quarters is 3 times nickels. Quarters is 3 times nickels. That gives her more quarters right there. For example, if she had 1 nickel, how many quarters would she have? 3. If she had 2 nickels, 6. If she had 3 nickels, 9. Okay, so that's just the one that is relating the number of items to each other. Now, this next fact looks deceptively simple, but this is where a lot of kids mess up. She has $1.60 made up of quarters and nickels. What do you think that's going to look like?
Not 25 quarters, 4 quarters. Right? 4 quarters equals $1. 4 quarters and then
Okay, pretend like you don't even know about this. Y'all are trying to do too much at once. Pretend like you don't even know anything. I'm just telling you a fact. She's got $1.60 made up of quarters and nickels. Yeah, this is what a lot of kids do. Q plus N equals 160. But that is not correct. Because if that's your equation, then you're telling me that quarters and nickels are equal. Because you're giving these both a value of... Don't worry about the Q equals 3N. Don't even try to deal with that. How much is a quarter worth? 25 cents. How much is a nickel worth? 5 cents. So we have to include the value of each one of those items in the equation that includes the total money made up of those items. So it's 25 cents times every quarter plus 5 cents, not 0.5, but 0.05 times every nickel. That equals $1.60. I mean, are you already solving it? I don't remember the answer. You don't want to put a 4 here. No, a quarter's not worth $4.
No, 4 of those equal $1.
Okay, so you're trying to multiply by 4?
No, I'm just saying, like.
Yeah, you are true. 4 quarters make $1, but that is irrelevant to this problem.
It's like $1.60. She has to have 4.
She doesn't have to have 4 quarters.
How else do you get? Oh,
Well, I'm going to show you. Okay, she could have a mixture of. We don't know that it's 4 quarters. It might be, but it's not. Let me just tell you, it's not. Okay, so my point is, one equation has nothing to do with the value of a quarter and a nickel. This one didn't include anything about money. It just said if you counted the number of coins, she's got 3 times as many quarters as nickels. Now, the one that said she's got $1.60 total, comprised of 2 different types of items, quarters and nickels. In that case, you have to include the value of each type of item that she's got. This is the money equation. It's got money throughout. Now, once you get your equations set up, you have to decide how you want to solve it. Graphing is probably, or using the calculator here is probably not the best way to go, because you'd have to know which is x and which is y. I would just leave it like q and n. And I would either do substitution or addition. Those are my 2 equations, and I've got to solve the system somehow. Now, let's talk about how to make it more user-friendly. The bottom equation, I don't like working with decimals if I can avoid it. It's super easy to make this whole bottom equation just have whole numbers. Just move the decimal over 2 times. So we could turn these all into whole numbers. We're basically multiplying by 100. So we could just make this 25q plus 5n equals 160. Are y'all okay with that?
Yeah.
I just moved all the decimals over. That's not a decimal. Over twice. Now you have to be consistent. You're going to have to move the decimals the same amount of time for each number. What do y'all want to do? Substitution or addition? Okay, addition. Usually I do addition. On this one I'm just going to tell you it's set up nicely to do substitution, but I'll do it both ways. If I want to do the addition method, the elimination method, your q's and n's and equal sign has to be lined up. So this 3n is going to have to come over there. So that would be q minus 3n equals 0.
So really the hard part is just finding those.
And now we still got to make something cancel. Multiply the bottom equation by a negative quarter, by negative 25. Then you would have negative 25q. Negative 25 times negative 3 is positive 75n, and negative 25 times 0 is still 0. And now your quarters will be eliminated. What's 75n and 5n? 80n equals 160. How many nickels? 2. How many quarters? 6. Put a 2 in here and quarters would equal 6. See, it's not 4. Now, let's make sure it works. How much is 6 quarters? $1.50. How much is 2 nickels? 10 cents. What does that add up to? Is that how much she had? Yeah, that's the winning combination there. Yes. So you're guessing and checking, basically. But you're not always going to have a simple equation to guess and check from. So I want you to pick a method you like and go with it here. Let's go back to the beginning. Q equals 3n and 25q plus 5n equals 160. The first time I did this, I did it substitution. It's set up real nicely for substitution. Sometimes that's easier. Q equals 3n. What can I put in place of this q right here? A 3n. So instead of 25 q's, I've got 25 3n's. That's 75n plus 5n equals 160. 80n equals 160. What does n equal? 2. Most of the time I do addition, guys, but sometimes substitution is easy. This one was set up nicely for substitution. And then again, nickels is 2, so quarters would have to be 6. But you can do any method for any problem. All right, let's try another one. Paul has 30 coins in dimes and quarters. Their total value is $4.50, so we've got a mixture of different items and they are worth different amounts. We want to know how many dimes he's got, how many quarters he's got. Confused already? We haven't even started. It's okay. How about this? He's got 30 coins, and some of them are dimes and some of them are quarters. What would that look like? D plus Q equals 30. That has nothing to do with money. I didn't talk about how much money he's got in that equation. I just know that if I counted the items, there's 30 of them. And some of them are called dimes and some of them are called quarters. That one has nothing to do with money. That's just the number of coins. Now, the next one. He's got $4.50 made up of these different priced items or different worth items. This is where you must put the value of each item in there. 0.10D plus 0.25Q equals the $4.50 that he's got. So one of them is just about number of items. 30 total items, nothing to do with money, and one of them is about the value, and the one that's about the value must include the value of each different item you've got. Right, Kenny? Sure. I would definitely make these whole numbers. I would make this 10D plus 25Q equals 450. And this one to me is set up nicely for the addition method. What could you multiply by? Negative 10. If you multiply the top equation by negative 10, the dimes will cancel right out. How many quarters did you get? I got 10. I made the dimes cancel and I got 10 quarters. There was 30 total coins, remember? So if 10 of them are quarters, how many of them are dimes? 20. I went back up here and did 30 minus 10 is 20. If I were you, I would check it. How much is 10 quarters? $2.50, right? It takes 4 quarters to make $1. 8 quarters makes $2. 2 more would be $2.50. How much is 20 dimes? $2. Is that the right amount of money? Yeah, $4.50. 30 coins that add up to $4.50 made up of dimes and quarters. That's got to be the winning combination. And I didn't have to guess and check. Okay. Now, this one's not about coins. This is about a mixture of two different priced tickets. We've got some student tickets and some adult tickets that were sold to a play. So the first two sentences are just facts. You're going to need the cost of each type of item when you deal with the money equation. So one equation is about money. Who could tell me the money equation? The first 3 sentences help you set up the money equation. Two times every adult ticket, because the adult tickets are $2 a piece. Plus 150 S plus 1.5 S equals the $550. This is all about money. If I'm talking about how much money was brought in by 2 different priced items, then I have to include the value of those 2 different types of items in that equation. The second equation has nothing to do with money. It's just relating the number of adult tickets versus the number of student tickets. Adult tickets was or is 100 less than 3 times students. 3s minus 100. Now, sometimes the equations need to be made a little bit more user-friendly. On number 2, you could just leave it exactly like that. If you don't mind having a 1.5 in there, that's fine. But you could also make them all whole numbers. In this case, you only have to move the decimals how many times? Once. So if you wanted to, I'm not saying you have to, but you could make this 20a plus 15s. Now you got to change everything. Equals what? 5,500. You have to move. If you're going to move one decimal, you got to move them all. And in this case, you had to add the zeros on the 2 and the 550. Now, you also have to decide if you're going to be an addition person or a substitution person. Either would work pretty easily. I usually do addition, so I would probably move the 3s over here, because addition only works if you're adults and your students and everything's lined up. And then make something cancel. Yeah, if you move the 3s over here, it's going to become a minus 3s equals negative 100. Watch out for your signs. So all I had to do was move one thing over, and now it's going to be super easy to make something cancel. If you multiply that second equation by 5, then the students will cancel. Somebody last period chose to multiply by negative 20. What would that do? That would make the adults cancel. I didn't get either one of those. Okay, first of all, let's make sure we got the same equations. Did you start out with 20a plus 15s equals 5,500? And then a, we moved the 3s over, so a minus 3s equals negative 100. Yeah, that's, you got to watch out for your signs. That was a... Okay, then I multiplied the bottom equation by 5. 5a minus 15s equals negative 500, yeah. And then the s's will cancel. Yeah, you gotta watch your signs and all that stuff. I got 200 adult tickets. Well, pick an equation. I would go back to my original. I usually go back to my original. Like this original equation right here. It'd be real easy to put a 200 in for a. So I put a 200 in for a. 200 equals 3s minus 100. I moved the 100 over, and I got 300 equals 3s. So the student tickets was 100. So then adult 200, students 100. Yes. Yeah, let's do it substitution. Okay, so let's go back to our original equations. 28, did you get rid of the decimals? Did you have 28 plus 15s equals 550? Okay, and then a equals 3s minus 100. This is set up nicely for substitution, because wherever I see an a, what can I put in its place? That's an s, not a 35. 3s minus 100. So instead of 20 times a, I'm going to do 20 times 3s minus 100. So I'm taking this a out right here, and I'm going to put 3s minus 100 in its place, plus 15s equals 5,500. So this is the substitution way. 60s minus 2,000, right? Plus 15s equals 5,500. 60s plus 15s is 75s S, add 2,000s to both sides, and you get 7,500 over here, and you get 100 students. So you found the students first instead of the adults. And then take your student answer and go back up here. What's 3 times 100? 300 minus 100 would give us 200 adults. Yeah, either way would work. Okay, try this one on your own. I tell you what, how about you just set up this equation, because I want to get on to 2 more problems that are a little bit more difficult. Let's just make sure we can set this up, and then we'll move on. Who can give me the number of coins equation? No, just the number of items. Yeah, D plus Q is 28. That's just counting the coins. Has nothing to do with how much money you've got. It's just there's 28 items. Some of them are dimes, some of them are quarters. Who can give me the money equation? 10D plus 25Q equals 460. I went ahead and moved all the decimals over. Yeah, you could have 0.10, 0.25, 4.60. And if I was actually going to solve it, I would absolutely move those all over and make them whole numbers. This one's set up nicely for addition. If you multiply that top equation by -10, the dimes will cancel out. You see what I'm saying? All right, I want to move on to some of the trickier problems. See if you can set this one up. Kind of. It's the second sentence that I'm worried about. Okay, the first sentence is enough to write your money equation. She's got $2.20. That's the money she's got. Some of them are dimes and some are nickels. So what would that one be? Not just D plus N equals 220. No, 10D. 0.10D. The one that's about money has to include the money in there. Plus 0.05N equals 220. And when I go to solve it, I would absolutely make those whole numbers. 10D plus 5N equals 220. Okay, so that's the money equation. The tricky one is the way they worded that second sentence, and they do this a lot. This still confuses me, honestly. I have to stop and think about this. She has 5 times as many dimes than nickels. What does she have more of? Dimes. So you need to make sure you write an equation that gives her more dimes. You would have to take her nickel number and do what to it? You would have to take her nickel number and multiply it by 5. But a lot of kids see the 5 times next to the word dimes, and they want to do 5 times D. But it's not 5 times D. It's actually 5 times N. Doesn't this give her more dimes? Yeah, if she had 1 nickel, that would give her how many dimes? 5. If she had 2 nickels, this would give her 10. If she had 3 nickels, it would give her 15 dimes. You see what I'm saying? You've got to take the nickel number and... Yeah, another word to say it is for every nickel she's got 5 dimes. When I read this, I ask myself, okay, what are they trying to tell me there's more of? 5 times as many dimes. That's telling me she's got a lot more dimes than she does nickels. That means you would have to multiply her nickel number by 5 just to equal up to her dimes, not the other way around. If you wrote it like this, if you did it like this, what does she have more of there? That gives her a lot more nickels. That's not what this equation is saying. Okay, for example, most kids when they read this can understand that this means there's more dimes. Do you understand this means there's more dimes? So let me just pretend, oopsie, what did I do there? Okay, she has 5 times as many dimes as nickels. So sometimes I just write out to the side, okay, well, if she had 1 nickel, how many dimes would that be? If she had 2 nickels, what would that be? If she had 3 nickels, what would that be? That's more dimes. So what am I doing to the nickel number? I'm taking the What in the world is going on? I'm taking the nickel number and multiplying it by 5. That's how I'm finding the dimes. So that's the set of equations you would use. This one's set up nicely for substitution. Right, Zoe? Okay. Try this one, folks. We're actually going to work this one all the way through. Okay, you want to work it out? If d equals 5n, so I'm going to put a 5n here. That would be 55n equals 220. He wanted the answer. That would be n equaled 4. Okay. Try this one. There's some like this on your homework, and I wanted to make sure we got to these. Please read this. Let it sink in. I'm not giving you that much homework tonight, so you better really do it and try it. I'm only going to give you like 6 problems. But please make sure you understand how to set these up. The way this is worded is very confusing, and I promise you there's some like this on your homework. Okay, first of all, it's confusing because we're talking about the same items. They're both pieces of candy. It's not like we can use a Q and an N for quarters and nickels. They're both candy. They're both C. Plus, they keep referring to the type of candy by its price. So you've got just a confusing sounding sentence here. On ones like this, I make up my own variables. 2 different prices, so I call them C and E for cheaper or cheap and expensive. Okay, now, and then I go back through and kind of reread it using the word C or the letters C and E. So instead of the number of 25-cent pieces, I read that as the number of E pieces, the expensive pieces, is 8 more than the number of cheap pieces. That makes it easier to me.
So then it's
25E plus 20C, or 0.25 plus 0.20 equals 425. That's the money equation, because you've got a bag of candy that costs 425, and some of it's made up of the cheaper ones, and some of it's made up of the more expensive ones. So there's my money equation. And if I want to make them whole numbers, no big deal. 25E plus 20C equals 425. Now, the other one, the number of 25-cent pieces, I'm just going to reread that with E instead of 25-cent pieces. The number of E's is 8 more than the number of C's. E is C plus 8.
Oh, 8 more, not...
Yeah, there's my 2 equations. Solve them. It's equally easy to do either substitution or addition here, I think. Pick the way you like the most and go for it. If you get something negative or a decimal answer, something went wrong. Ooh, I did something wrong too. Hold on.
Oh yeah, yeah, yeah. 513. I thought you did 5 over 13. That's why I was like 513. Yeah, yeah. I got 13 for this one, and then I put. I know. You need your own paper.
Okay. I messed up the first time I did it too. I got 13 of the more expensive pieces. And then the cheap ones would be 13 equals cheap plus 8. Subtract 8. Cheap is 5. So 5 of the cheap ones, 13 of the expensive ones. Now, if you didn't get that, let's talk about what you did. Let me solve it the way you did. Who needs to see this worked out? Okay, what method did you do? You did what? The elimination method? Okay, so the first equation is okay. 25e plus 20c equals 425. You've got to move some stuff around. So what's going to happen to this guy? Okay, well, tell me exactly what you did. Okay, but to do the addition method, your e's and c's have to be lined up. Okay, so what did you do to this bottom equation? 25e plus 20c equals 425. This one was already in standard form. And then e minus c equals 8. You moved that c over. You had to do that first. You got to line up your e's and c's and all that good stuff. Now what? Okay, by negative 25. Now watch out for your signs. That's going to give you negative 25e plus 25c equals negative 200. Now when you add them up, your e's cancel out. I'm getting 45c equals 225. 425 minus 200. And 225 divided by 45 is 5. So there are 5 cheap ones. And then the expensive ones are 8 more than that. So 5 plus 8 would give me 13 expensive ones. So you did the same thing I did, except you made the e's cancel. I made the c's cancel. All right, did anybody do substitution? And need to see it worked out? Substitution would give you the same answer as well. Are we okay with that one? Okay, that's the last one I'm going to make you do today. Your homework is on page 350. 1, 3, 5, 7, 9, 11. The first column. And I'm only making you do 6 problems. 1 through 11, first column, basically. Before you leave, I want you to look at page 350. Number 9 is one of the tricky ones. Number 9 is kind of like this one. It's talking about 2 different types of pencils. Ones that are 20 cents and ones that are 25 cents. So I would call them C and E for cheap and expensive.